Hello students, this is exercise week 5 in emerging trends in software engineering. So in this week exercises, you should do parts 8 and 9. Part 8 is about interactive clustering. So we will plot some LDA text clusters on the screen, and you can explore the contents of the clusters, and then you report some findings that you find in your data. Task 9 is about finding hot and cold topics. So which are the most trendiest topics that are increasing and which are the ones that are decreasing. So we will do this by first clustering and then seeing which clusters increase or decrease the most. Okay, I'm here in RStudio again, and I start out by running the initialization script, and then I move to the file interactive LDA cluster.r. First, we will load in the necessary packages, and we will load the data file that I use in this demonstration. As you can see, all the libraries are successfully loaded, and we can see that again we have the 3,591 articles from transactions on software engineering that I use as my demonstration data. Okay, in the file there are a couple of spots where you want to stop and make some adjustments. For example, here in line 28, executed simultaneously, there are the my stop words again. So you definitely want to edit this list. Another place where you might want to make edits is in line 36, 37, 38, and 39. Because here the vocabulary creation is done and some limits are put to the vocabulary creation. For example, we have a limit that the term, a particular word, that is, should appear in minimum of 10 documents. Now you might want to adjust this number to 5, or you might want to increase it to 50, for example. This depends on your data set. I will just leave it at 10. We have set the max vocabulary size to 40,000. This is simply to speed up the analysis. We might want to increase or decrease this depending on the data we have. Finally, there is the doc proportion max value that says terms that appear in more than half of the documents are excluded. And what this means in practice is that this is actually another way of doing stop word removal. So by default, I have set it to 50%, but we could set this down to 10%, which would mean that only words that appear in 10% of the documents are kept. And if a word appears in 11% of the documents, it is removed. So we can think of it as automated stop word removal, because stop words are those words that are very common or words that we simply don't care about. Okay, now I will just execute the rest of the file and we can look into the results. We can see it does clustering and iterates over those clusters, and when it's complete it will open up a browser window. Okay, now we are in the browser window and we can see the individual clusters. We start to explore this from the top. We can select topic number 18, and we can see that we start out by having a not so relevant cluster, as the most probable words for this cluster appear to be 1, order, number, set, 2, IEEE, and so on. So it basically contains a list of stop words that we might want to remove. If we jump into topic 12, we can see that this is about real-time systems and real-time system requirements. We can see that the most probable words for it are time, system, real, and so on. We can also see from this interactive clustering where else these words appear. So if we go over time, we can see it is most probable in topic 12, but it also appears in these other topics. Now, if we go over the word system, or systems, excuse me, which is very common, we should see multiple topics. And it is actually, well, we see multiple topics, and we can see that it's also distributed quite evenly. So it is very common with real-time systems, but then it's also common in topics 4 and topic 7. Now we can also investigate topics 4 and topic 7 to see whether this is true. And if we go to topic 4, we can see that this is about distributed systems, distributed system networks. And if we go to topic 7, we can see that this is about system design, or systems design and formal architecture, and so on. So we can see that the word system might not be so relevant in our case, as it can be part of many topics, distributed systems, real-time systems, and so on. In this interactive clustering, there is also a slider, sort of a relevance metric, which allows you kind of to do the same things as stop word removal. It considers the local property of a particular word over its global property. So, for example, systems is a very frequent word overall, but the estimated turn frequency within this document is only 700. And this lists then in the estimated local frequency. But by adjusting the slider to 0.3, which I think is the suggested value from prior work by Sievert and Schirlew, as we can see from the reference 2 on the bottom. Oh, we cannot see. You cannot see. Now you can see. Right. So this one. Okay, so if we go to 0.3, we can see that system actually goes down. So it's not anymore the most descriptive or the third most descriptive words for this topic. So the word importance or the most descriptive words for this topic now are design, system, architecture, knowledge, description, and so on. So basically this lambda metric here, by setting it to 0.3, you can adjust and find more relevant words to the particular topic. Okay, now this is a good topic as an example. So we have topic number 8, and we can see very common words, sort of stop words, as being the most descriptive for this topic. Result, case, cost, study, and can. I mean, those words could appear in many different kinds of software engineering papers. To see what this topic really is about, we can adjust the slider to 0.3, and we found out that this is actually about failure probabilities and failure estimations. Okay, so your task in this interactive clustering is to study these clusters for all 3 data sources you have and report something like 3 to 5 most interesting findings that you can discover by looking into these clusters